Welcome to the Clean Power Hour Live. I'm Tim Montague, your co-host. We are doing our bi-weekly solar and storage news with none other than the commercial solar guy, John Weaver. Welcome to the show, John.
Hey Tim, uh, it is very nice. It's overcast and cloudy here. I was going to say how a nice, wonderful sunny day, but we had that yesterday, and I had wonderful site visits at solar projects that make me happy. So I hope you're doing okay, Timothy.
I am
All
in Dallas, Texas, actually in Richardson, which is a suburb of
right.
Texas, at Innovation Day with the team at Chin Power Systems and
Hmm.
several hundred clean energy professionals. It's such an
Cool.
awesome thing. This is day two, and there's
What kind
training
of show?
sessions going on. Sorry?
What kind of show? What's it about?
Oh, this is their annual conference that Chin Power Systems, the three-phase string inverter and battery storage company, makes or puts on for their customers and their partners. I am a partner. I'm a media partner.
All
They're a
right.
major sponsor of my show, of course, and I do a lot of content creation with their staff and their customers. If you're a Chint customer, reach out to me because I want to tell your story, whether we talk about Chint or not.
Yeah.
So, but yeah, it's a wonderful event. I've been here. This is my third year, and it keeps growing. There's about probably all said 300 people here this year, and next year they want to get 1,000 people. So
Cool.
we'll see.
All right.
Um, but yeah, it's a very niche, very dense conference. A lot of electricians, engineers, and solar geeks like me and you. So yeah, you should check it out sometime.
Cool.
But it only happens once a year in April. It will be in April next year. They don't know the date. It'll either be the first or last week in April. Um, Chint
Sounds
has
like
a
a
big
good.
facility here
I was gonna
in
say that sounds like a
Richardson.
good conference. Technical, focused on inverter layout. You can ask questions, you can exchange ideas with other designers. Um, I listen to our electrical engineer talking with people, and every conversation I always hear something. I'm like, oh, that's interesting. Most of it floats away because I don't get to use it on a day-to-day basis. But
Yeah.
design, getting better at design is something I'd love for us to be. Just be more experienced, learn our inverters better, what the strings can do. Being in the Northeast, we have at low angles on our roofs, we can push our strings a little more, but it'd be great to know how so that
Mm.
we can size things well and not waste and not risk our inverters. And
So here's a geeky topic that came up last night. I was talking
all
with
right,
Dr. Z, who's the head of their storage division, but he's also a power electronics geek.
hmm,
And we were talking about what I call non-injection, or what others might call um, zero. What's the expression? Zero, where you're not feeding solar onto the grid,
all right.
right? I call it non-injection. What do you call it?
Non-export,
Non-export or zero export.
zero
Yes.
export. Yeah,
So apparently, if you're in California or Hawaii or Arizona, you know well about this because this is
yeah.
an important thing in those markets.
In
And
Massachusetts, occasionally.
yes, and in Illinois, occasionally, the circumstances in Illinois that it becomes important is if you have an interconnection problem where the utility says, well, we'd love to interconnect your solar project, but we're going to charge you $3 million for an infrastructure upgrade. And a certain installer I work with has a situation like this on their hands. And of course, that is for a CNI project, that's a deal killer, right? But the way around that is to say, well, Mr. Utility, we would love to do this magic called non injection, where the inverter will just automatically see that it is about to feed onto the grid and it'll turn itself off
Sort
or
of. It
reduce.
will it will adjust the MPPT arrangement on the modules, I believe. I believe it'll actually throw the modules out of efficiency so that they, instead of producing electricity, won't produce it. I think technically might be how it happens. Different places do it different ways.
Yeah. Um, But so my question for you is, have you been
Hmm.
involved directly in a project where you had to engineer non-injection?
Yeah, we've had a couple non-export projects. I'm thinking of one right now at the
Okay,
YMCA in Wareham. And the way
cool.
we did it there, though, was that we had a battery, and it was all behind the meter, and it's all getting used on site. I've also had larger projects where technically it was a non-injection, and so or non-export, and in that case, but the reality was that the demand on site was just massively larger than the solar project, the roof that they had space. So while
Yeah,
it was a non-export system,
yeah,
and that helped for interconnection, just got through a little faster. The
yeah,
reality was that it was always going to be a non-export system because the building was always going to absorb all the juice. But when it comes to interconnection and impact
yeah,
studies, it's great because now we no longer, there's a lot of risks that the utility has to calculate when you do an export system. And in places where the substations are full or the power lines overloaded already, this
yeah.
is great. So yeah, so
Yes.
non-injecting is great. So how does CPS work with it differently, or what do they do? Or are they
Well,
just talking about it?
what it turns out, so historically, when I was at Continental in Chicago, we solved this problem using a device called a Schweitzer relay, which I don't know very much about. But it turns out that many inverters have native capabilities now to do this non-injection. Chint, it turns out, has had that technology built into their inverters, but they haven't turned it on yet. But it's coming now in the United States. And so they're going to start doing some pilot projects with their installers on a case by case in different parts of the country. Um, but some of their competitors, SMA, I think, and SolarEdge have had this rolled out already. So anyway, so Chint is playing a little bit of catch up, but they actually have the secret sauce already built in. It's mostly a software thing, um, but it's a combination of software and hardware. And then you also have to have a smart meter, an extra smart meter. I didn't quite understand where on the grid, but anyway, good thing for us solar professionals to know about, right?
Yep.
As the industry matures and attachment rates, sorry, not attachment rates, but penetration rates go up.
Yeah.
Um, so we better get into the news though, John. This is a good topic, but we could probably talk all day about non-injection.
Yeah. Inverter conversations are borderline indefinite. They are they are the fun of our industry.
Did you really not know about Innovation Day?
No, there's so many conferences out there that I don't know anything about. I only go to one or two per year. I'm so busy and
Well,
I
a
don't
lot of
want to
them are
travel
very
too much.
expensive, but this is virtually an all expenses paid thing. Like all you have to do is get yourself here, and then they pay for your hotel and all your meals, which is
Nice,
amazing.
nice,
And you get to
nice.
network with a group of super cool solar professionals.
All right. Well,
And you get to geek out with real technical geeks at CPS to boot. So it's like a super win-win.
I
Um,
like it.
it's my favorite energy conference now. So
All right.
put it on your calendar. Um, all right. Is this the first commercial-sized perovskite solar panel for a large manufacturer? It also happens to be greater than 800 watts with an efficiency of just over 26%.
Yes.
I want to know, is Kalux involved in some way?
No. Well, I don't know. I don't
No,
know who that is.
you
This
don't?
is Trina. I mean, I know that name, but I don't know who they are relative to this. There's lots of names out there,
Well, they
but
make perovskite coatings for solar panel makers to add to their
cool.
solar panels. So maybe it does. I don't know.
Well, I doubt it's here, but we don't know. Because this is a Trina module that they introduced, and it's a tandem cell versus a coated glass product. It seems, however, there's limited data on it. I've only seen this one press release and nothing else. And this press release has been shared around the world, and that. But it's to my best knowledge, from a large manufacturer, maybe the
Yeah,
first certified large scale product that's been out there. And it's a 3.1 meter utility scale module. So it's like one of the biggest modules you can buy.
Mm-hmm.
but it's also the highest wattage module I've seen within
Mm-hmm.
that form factor. And I did my rough math, and if you divide 800 by 3.1, it comes out to be about 26% efficient solar panel, which would be amongst the highest efficiency solar panels you can find.
Yeah, and
Well,
that's the whole
technically,
point, right? With the tandem is you're taking the PV and then you're sandwiching on top some perovskite, which gives you extra juice,
yes,
right?
yes.
You're catching more photons, basically, right?
Catching more. Yeah, I guess you're catching more. Yeah, because you have two layers that are, and you're actually catching different photons.
Yeah, I think you're catching
Because
different
the perovskite,
photons.
yeah, they have these cool curves that show the wavelengths of light.
Mm-hmm.
Wavelengths of lies, Tim, all lies, coming from the sun. But they show these curves of light, and so like you'll have one chunk that gets one type of silicon, and then another chunk of light that gets the perovskites, and these are called the band gaps. Um,
Right.
and so the perovskite, though, from what I've been reading, is actually being used as the main solar panel because it's harder to use, whereas the silicon is being used as the secondary panel because we're really good at working with it and managing it. So, for instance, GCL, they have a perovskite module, and their perovskite module is about 19 to 20% efficient. Their silicon module is only 9% efficient. And you would think, oh, but we can do a 25% silicon module. Yeah, you can, but
Yeah.
we can't combine it with a perovskite in that setting, at least not yet. So it's interesting to watch. And I was just excited to see this headline. The module
Yeah.
doesn't exist yet. There's no, like, nobody can touch it. There's probably 10 of them in the world, maybe 100, I don't know. But we're now seeing a full-sized perovskite module at 26%, and it's not from Oxford PV, who I'm not emotionally 100% on yet. I think they might try to play the patent game and limit the rest of the world. They've been saying they're going to launch a module for years, and I've only heard of a module once coming out of them. So it's just cool to see someone else. Now, I will say, I also worry that it won't come to the United States for a while because, well, tariff stuff is another conversation, but more importantly, it has to do with these patents. For instance, I'm hearing that TopCon modules aren't coming to the United States as much.
Right.
PERC is going to hold longer here
Yep.
because of patent arguments.
Yep.
Whereas I just read an article in Europe, they're like, PERC is gone. Um, TopCon is it because of the higher efficiency, the cost
Yep.
structures that come from powerful modules, lower the balance of system, and you know it's a little dance, it's a little change. So we'll see, but it's cool seeing it hit the world. And if we really do get modules up to 34% per, uh, it's just going to be great. I mean, I've done some math before. Roughly every 1% drop or 1% increase in efficiency is about a 5% drop in levelized cost of electricity as you
Mm.
move from, say, 20%, 22% to 34%. So we'll
Really?
drop roughly. It's a curve though. Like at 20%, moving up 1% is 5%. At 25, moving up 1% is 4%. So it's a
Oh, okay.
curve, and
Okay.
it drops a tiny bit all the way up. But by the
Yeah.
time you get to like a 34% module, I think your effective levelized cost of electricity will drop like 40%, 30%, 50%, some really nice, big, chunky number. And so I'm just looking forward to it. I'm looking forward to new tech. I always like new tech.
Yeah. Yeah. I had Scott Graybill on the show, I think last year or year before last. A company called Calux, Caelux. They're
Hmm.
making a perovskite coating in LA. They're in Pasadena, California. They have a 50 megawatt plant. So it's, small potatoes. It's basically pilot scale.
Hmm.
And they're not announcing publicly any partnerships, but they're working with a variety of panel makers to do what Trina has already done.
Yeah,
So it's good stuff. We should probably move on. You found a
keep it.
story about batteries in China.
Yeah, I wanted to start high level. the battery article that we're sharing here, it's simply the next large winner in a massive capacity bid, 6 gigawatt hours. Um, and the price of it is $65 per kilowatt hour, fully deployed. And
That's very
so,
low.
yes, sir. Like right now, if you're buying batteries in the US, you're at the best, you're getting them at $150 per kilowatt hour installed, but you're probably spending 250 to 300 still. It's just the reality of pricing as of now. But I hear some people, I've heard a guy say 175 is what he's pricing his batteries at fully installed. So that's a pretty cool number. But this is 65. And I just wanted to chat a little bit about why, one of the reasons why this is happening, just to bring it to our readers' attention and yours. Um, and you probably already know, but battery cell sizes are massively expanding. And battery cells used to be 300 amps. Now they're getting up to 500, 700, even some are, I don't know if I've seen 1,000 amp. I might have, but they're getting really big. And these large battery cells, they're like physically like, this big now. They're like size of a Coke can or bigger.
Yeah.
Because of that larger size, I guess they're able to pack more density into these battery packs and then more battery packs into the containers. Now we have shipping containers that are up over 8 megawatt hours. And so when you have bigger cells, they have fewer connections, they have simpler machines. When you have more density within the same supporting package, it's like putting more watts within the same aluminum frame. The aluminum frame still costs $1, so to say, but the price per watt keeps falling because you get more watts within it. That's what's happening with battery cells and battery packs and battery kits. And it's been happening for about a year or two at least. And last RE Plus, I got to talk to a few folks who said the next revolution in batteries is ongoing, and it's just us scaling these cell sizes. Um, I saw a headline, or I was reading something, BYD said that last year their batteries dropped 20-25%. This year they expect another 15 to 20%. So
Wow.
batteries are going to keep going down. And I've been wanting to bring this up on the show for the last few shows.
Yeah.
And then this second bid came out. The first bid from this group, because this is the second one of this size, the first bid had BYD winning it at $60 per kilowatt hour. And that was the first time, this was back in October, November, December. That was the first time that these crazy cheap numbers came out to the world. We were already seeing systems at $100 in the headlines sneaking around,
Hmm.
but then
Yeah.
65 just kind of took a sledgehammer to it all and said, all right, next generation, we're here. Let's do it. So I just wanted to bring
And
that
so, for
up.
our listeners not on YouTube, this is a story called China's Huadian announces winners in 6 gigawatt hour best tender with average bid at $65 per kWh. The story is in PV Magazine Energy Storage, which is a separate website now,
Hmm.
ess-news.com. So kudos to PV Magazine for branching out and creating a storage website. I think that's a good thing and interesting story. So thank you, John, for bringing us that story about cheap batteries, which we're going to
Yes.
see a lot of.
Yeah.
Um, if we get to see the future at all, we'll get to see really cheap storage.
Tim, what are you talking about?
Yeah, I know, bro. It's tough. It's tough that we have to
Yes.
ask that question, but it is a
Yeah.
question.
This is where we are,
Um,
Timothy.
so, are we going to stick to a 30-minute program today?
We never stick to 30-minute programs, but we'll find out. Let's hit it hard and let's see if we can do it.
Okay. So, you brought the butterfly back, bro. Uh, you're on blue sky again, man. I don't know.
Absolutely.
I don't know if I can handle this.
I'm on Blue
Um,
Sky every day. That's where the good
so,
news is getting shared.
what's the story while I bring the blue sky story up?
This is just my project of the week. This is downtown in New Bedford, and I wanted to show off some of the little finer things that we have to deal with. Um, The this is a interconnection kind of story post. So we just got final interconnection approved on this project. It's 666 kW DC, about 552 kilowatts AC, and I wanted to talk about some of the just a couple neat little nuances of it. So it's 666 kW DC. It's spread across 14 roofs, and there's 5 unique interconnections. The interesting thing about this, and I wanted to show it off
Is
in these
that rendering
images.
properly now?
Well, let's see. Yeah, that looks nice.
Okay.
So this is like a map from the utility, one of their drawings, and you can see like where they have these different buildings and those M's, those are our different interconnection points. And so we have 5 of them, and there's 5 unique projects behind this, in this neighborhood of housing. And if you go one of the images to the left,
To the left?
yes. So
Okay.
this document, you can't fully see it because it's kind of smallish writing, but what this is, it's a breakdown of the cost estimates that we have to pay to upgrade the power grid, which includes 2 300 kilovolt transformers
Yeah.
and several and about $100,000 of upgrades to the substation for what's called 3VO protection. Now, if you look at this document, it's really interesting. There's actually $542,000 of upgrades that were spent on the utility. We got a cost share portion of it, plus some of our own upgrades. And it was just really interesting to look at the different labor, how they break it up, the different work components, and the cost share, even. And cost sharing is a new thing that I've had now in a couple of projects in the Northeast where the state tries to figure out how to pay for substation upgrades without putting all the financial pressure on one party.
Mm.
And so I
Yeah.
don't know exactly how Rhode
I
Island's
like
doing
that.
it. Yeah. So in Mass, we just had a substation upgrade, and the substation upgrade was for um, down on the Cape, the Cape off of Massachusetts. And I don't know the exact price of it, but I do know for every kW that you connect to that substation, you now pay an upgrade fee of about $319. So it's not cheap, it's zero point 0.3 cents a watt, zero point 0.30 cents a watt, something like that. And that's for the historical upgrade that occurred. And so now we cost share. And that's what's occurring here. So for this document, you actually see all the other projects that are on the substation, 11.4 megawatts worth. You can see our new project at the top of that image. If
Hmm.
you're looking at this on YouTube, you can see the 553 kW,
Yep.
and you can just kind of get a picture of what's happening here. And so I just thought it was a neat little insight into the development process of interpreting grid upgrades and how they're shared and that type of stuff.
So how long does it take to get an interconnection agreement with this utility?
So this is Rhode Island Energy, and this one we started submitting in late October. So we're now in April, and so we're talking 6 months of a lot of back and forth.
That's not bad.
No, no, it's not bad.
You
It's
know,
at half
in
a meg.
Illinois, we have a really troublesome situation. In northern Illinois, it's not bad. Okay, in ComEd territory or PJM, it's not bad. The For DG interconnection, it might be 6 months. In central and southern Illinois, in Ameren territory, it's 3 years is what the utility will tell you if you need to go to a level 4. So if you're stressing the grid in any way with your solar project, right? It could take, they say, 24 to 36 months. And as a result, community solar developers are avoiding Ameren territory altogether now. They just said it's not worth it. It's too long a wait. And I'm just going, John, it's not rocket science. Like, why can't the utility figure out a faster way to clear this queue? And of course, the developers and the installers are up in arms, and they're griping, as they should, to the IPA and the ICC, the the Illinois Commerce Commission is the organization ultimately.
Hmm.
Um, that is our PUC. Maybe you call it a PUC in
Yeah.
Massachusetts. I don't know. Yeah,
Yeah. Public utility. Yep.
yeah.
Interesting.
Um,
3 years. That's very debilitating.
it's debilitating, and they know
Oh,
this. They know this, and this is just their way of fighting back. I think, right? They're just going, "Hey guys, we love you, but we're going to screw you anyway."
oof, that's rough. That's rough. Yeah.
It sucks.
Yeah. Interconnection is stressful. I
I have.
mean,
I'm an owner's rep on a project. It's a small project, 300
hmm,
kW. That's at an RV park. It's a great, lovely project for the owner, and but it's a single phase infrastructure, and
mm,
so the 300 kW is a stressor,
yeah.
and now they're gonna have to scale the project back to 100 kW, which will offset maybe 30% of their load instead of 80% of their load. Um, if they want to get a timely interconnection, meaning a level 2 instead of a level 4. So it's TBD what's going to happen with that project, but it's really no bueno for anybody involved, including the installer, who's worked very hard to, do some preliminary engineering and file a preliminary interconnection application. Sour apples.
Mm, that sounds
Because
rough.
the alternative is to upgrade the infrastructure to three phase, but that's also costly.
All right.
Probably on the order of $100,000. Have you ever had to do that, to upgrade from single phase to three phase?
I'm actually doing it on a project right now. The site visit I did yesterday
Yeah.
is we're building a 200 kilowatt AC, 600 DC with some batteries at the end of a long road, which is on private property. And the private property takes a single phase line off of the main street. And it's about half a mile down that private road. And we're in the process of dealing with that, of upgrading it from single to three
Do you have a
phase.
cost estimate?
Not yet, not yet. But what we're actually going to do is trench for the majority of it because we don't
Hmm.
expect there to be rock because we prefer to trench than to have the utility pay for poles and their work. And
I
there's
see.
also a bunch of trees and there's a road, so there's some dynamics where we think trenching will end up being more cost effective.
Why not boring?
I mean, I don't know. I'll talk with my guy, but
I love
we're
doing
easy, we're
that
good at trenching.
comparison. Is it
Yeah,
cheaper to trench or bore? And
interesting.
and I just like boring because I, I don't know. You don't have to dig a hole in the ground. Um, but yeah, it's always a question. All right, let's talk
Yeah.
about Myanmar. Let's be grateful that we don't live in Myanmar, John.
Yes.
They're in the aftermath of a major earthquake. It's horrible. Many people have died. This is on screen now. Myanmar earthquake disrupts solar wafer production, global supply chain. So, not only is it a catastrophe for Myanmar and the people, it's also somewhat of a catastrophe, apparently, for the solar industry. What's the story?
Yeah, so that area is nearby China. Myanmar and China share a border. There's also solar manufacturing in the country, and and apparently it's affecting solar factories, and it could affect solar wafer factories for months, is what a large manufacturer has said. And so it's just a perspective for us in the industry that our field can be affected by earthquakes and things around the world because making solar cells involves robots that are very very explicit in how they move in the space and how they're put together, and you start throwing them around and bouncing them against each other, or you mess up a building or you mess up the electricity, and very sensitive hardware gets limited. And so I'm wondering what's kind of effect is going to occur on the global market. I have a feeling it's going to be muted because we already have a lot of excess solar wafer capacity. So maybe it won't have a big effect. Maybe it won't have any effect. Maybe it'll have a small effect. I don't know. But at a minimum, it's just insight that, man, if earthquake hits, it could affect us somewhere. So just thought it was
Yeah.
interesting. And, you know,
Well, not
earthquake
to
sounds
mention the
terrifying.
tariffs that Trump announced yesterday on virtually every country on earth. Um, he just has it out for everyone, including, unfortunately, Thailand, where a lot of inverters, for example, are made, but also solar modules.
Hmm.
It's just going to make everything expensive. I, I don't
Yeah,
I don't I don't see how that's going to help our economy. The theory is that it's going to drive manufacturing back to the U.S., but that takes so long. We do see it happening because of the IRA, not because of the Trump tariffs. But
correct.
tariffs today could mean factory in 5 years. Uh, but then, of course, Trump won't be in office any longer unless he has his way and gets to run for a third um, term. But yeah, it's a global economy. I'm a fan of globalism. I think it's just uh, it's an emergent property of us becoming a massive civilization, right? We have colonized the entire Earth now and brought industrialization to the entire globe, basically. And so we're interdependent. I want China and America to be friends. I read a story in the New York Times about Huawei's innovation campus in China.
Hmm.
They said it was like Disneyland for technology.
Hmm.
And the journalist was frankly blown away at how advanced the technology is when it comes to things like humanoid robots. China is building a lot of humanoid robots. Huawei's been banned in the United States, right? You can't buy Huawei equipment. But
Yep.
guess what? They are a powerhouse and they are innovating their way out of the ban. They've launched a cell phone operating system to compete with Android and iOS,
Hmm.
which apparently is quite good. I used to have a Huawei laptop, which was excellent. I now have a Dell laptop, which is good, but I liked my Huawei better.
Interesting.
Shout out to Chris Letman. He's here. He's one of our faithful listeners. Thank you, Chris.
Hey, Chris.
And um, I will be dropping an interview with Chris Letman
Good.
about the solar panel industry and Imperial Star Solar, who make really good solar panels right here in Texas, in Houston, Texas. Imperial Star is not a household name yet, but I think they are going to be. So if you're looking for solar panels, talk to Chris Letman. You can find him on LinkedIn. He's very easy to find.
All right.
What's next?
Something cool has started to happen, and I'm going to share my screen. And I think
Do
this
it.
might be the first time it started to happen. So, can you see my screen? What's being shared there, Tim?
No.
All right, let me
Oh,
bring you into the
I
room.
have to click another button here.
All right.
There.
Ah, there. Now it's sharing. All right, let me mouse over a very specific thing. So first off, everybody, I'll describe this. This is the EIA. It's called the Hourly Electric Grid Monitor. So you can find it at eia.gov/electricity/grid monitor. And this roughly shows, roughly, for the lower 48 states, all electricity generation from all the sources in all kinds of neat little ways. You can look at batteries, wind, solar, you can look at it regionally, lots of neat things. And it has historical data. And historical data for a very tiny thing is what I want to look at right now. And something has started to happen for the first time, to the best of my knowledge. And I'm just going to point out one of the days. But I think for the first time in March, solar generation is sometimes the second largest electricity source in the United States. And that's interesting because, at minimum, it's really interesting because if we think about solar, it's still only 6, 7, 8% of all electricity. For
Right.
the like for January, it was 5%. For May, which is the peak month, it may cross 10%. But here
Hmm.
on March 25th, at 2 p.m. with this particular model, we see that solar was generating over 91 terawatts of generation out of maybe a total of 400. So solar was peaking over 25% of all energy at this particular moment. And it was number two behind gas. And it passed nuclear, which is roughly a solid 80 terawatts 24/7 around the US.
Mm-hmm.
And this is just cool. And I have a feeling sometime in April, we're going to see solar peak on a Sunday or a Saturday as the number one source of electricity in the US, if it doesn't get too hot too fast. I also have a feeling that in April, we're going to see 50% of our energy come from clean, non emission sources for the whole month. So that's my hope for the month of April.
Yeah. Yeah. So there's more solar than almost any other source except for natural gas, right?
Yes, yes, sir. Yes, sir.
More solar than nuclear, more solar than coal, more solar than wind by a long shot. Of course, wind fluctuates a lot.
Yes, yeah. Yeah, and if you like, for instance, if you scroll to the right, you can see that green loop right here, where that's wind peaking at 91,000, and it takes over as the number two source.
Yeah.
But what's really cool, you can go somewhere like here, which is, so if we look at this date, you see this is, all right, so I'm moving around on this screen here, trying to get my mouse in the right place. But we're looking at 318, so March 18th. We can see that the number one source was natural gas at 106. Number two was nuclear at 85, with wind and solar right behind it at 80 and essentially 80/80. So the three largest clean sources, nuclear, wind, and solar, are over
Mm-hmm.
240 terawatts of output, where coal and gas were only at 150. So we had 66% of our energy at that moment, something like that, is coming from clean, non-emission sources. Actually, if we add in hydro at 25, we're now talking 260, 270 out of 400. So maybe 70% of our energy was coming from emission-free sources at that moment. So it's just kind of neat to see it pop through in these charts, like the high level of clean stuff. So it's just not
Yep.
kind of nice. So there you go. There's some positive news.
I do like the EIA data. I don't like everything about the EIA, but I like their data.
Yeah.
So, should we talk about Hyundai or probably not going to get to all these stories, but what
All
else
right.
should we talk about today?
Well, we can talk about Hyundai real fast. So officially, as of a couple of days ago, you can now charge officially your Hyundai and your Kia at the Tesla supercharger network using your own adapter. Prior, your Hyundai or other vehicles could charge with what's called the super dock, or no, the magic dock, but that wasn't at all locations. And so you had to kind of poke around. But now
Yeah.
all of the Tesla network is available for Hyundai cars. And I have a Hyundai and I have an adapter, and I tested it this weekend and it worked great and I'm very happy. So it really opens up the network of where you can charge your car and where you can drive your car. And because the Tesla supercharger network is the number one way to charge a
For sure.
vehicle in the United States. And
Yeah.
so I was just really happy to see that finally hit and run with
You
it.
are
So it's great.
a Hyundai electric vehicle owner, right?
Hyundai Ioniq 5,
Yeah.
2022 is what I have.
Yeah.
We actually just leased a second one for my company, a 24. So one of my
Yeah.
coworkers is driving around in the newer version of my car, and they actually had the better trim too because they didn't have the cheap trim when I showed up. So whatever. So that's kind of cool. So yeah, I do like the car. I think it's a solid vehicle, and I'm very happy with this adapter. And that's roughly the same adapter that I have that I use to charge at Tesla stations.
Yeah. When are we
And you
going to
do
unify on a single port style?
well. I mean, I don't really like the concept of everybody only doing one port because it's
Mm,
we need to learn. We need to get better. I mean, maybe we can unify, but you know what? The Tesla charger is a better charger so far. I mean, there's less gear, less hardware. It doesn't fail as often. They're much cheaper. They click in fast. I don't know. I like people arguing over technology and competing, but you do have a good point. I mean, imagine if there were different gas stations. Well, I guess there are. You got diesel and you got gas, but I don't know. Ah,
Yeah, I just
let's
don't. I think we want one kind of plug.
probably.
We want it to be mainstream. We want it to be easy. I'm thrilled that Tesla's opening up the network. They
Yeah.
definitely have the most robust network. Kudos to Elon Musk for thinking of that and skating to where the puck is going to be. That's probably the last good thing he did.
Well, yeah. I could never. I don't know. Don't want to go on that topic today. Not today. But there's sort of a a focus now though in the United States at least on the Tesla charger, which I think is called the NACS, North American Charging Standard, is what they call it.
Yeah.
And the 2025 version of my car comes with an NACS standard plug, so you don't need an adapter anymore on Hyundais.
Yay for
Yeah.
that. Love it.
So maybe that's it. Maybe it's already happening. So it's moving. It's moving along.
Do you want
Well,
to
we
talk
cover
about
this.
the excavator?
Let's do one last thing and then let you get back to work because you got to
That
shake some
sounds
hands
good.
with some
That sounds good.
electricians.
We'll talk about your electric 422 kilowatt hour battery
Yeah,
Sany electric excavator,
420 something, dude. That could power your house for like a month and a half without solar. I mean, it's
right?
just it's just an excavator, but it's four. First off, that's a giant battery. Its size is what they said specifically, so the unit can work for 6 to 8 hours a day, which is very logical. Um,
Yeah.
the robot people, goodness, or Lumos,
Luminous.
uh, Luminous,
Yeah.
their upgrade for their robot for solar panel stacking was specifically to get them to the point where they could offer their robot for a
Yeah.
6 to 8 hour workday. I'm
Sure.
starting to like when I hear manufacturers say that. It makes me feel warm and fuzzy because this isn't a cool, neat machine they're building. This is a work creature that they're coming together with. And that means it's serious, get on site, do some work labor type of hardware. And I like that. And because it's a real piece of gear now. And
And it
it just
turns
kind of
out
feels good.
the drivers or operators, as they would be called in construction,
Hmm.
of these machines really appreciate the EV models because there's a lot less vibration and there's a lot less fumes. They're sitting in that cab and yeah, it's sealed, but they're breathing fumes
Yeah.
and they don't like that. And it's not good for their health. So this is a win-win, right? You can make clean electricity with solar or wind and now juice your construction site. It's clean, it's good for everybody. I love it.
Yeah,
Did they
I
say how much it
noticed.
cost?
You know what? I don't think I noticed that in the article.
Yeah.
Yeah, yeah. I mean, the only thing I noticed in cost was that they did estimate that the annual diesel cost for the unit would be about $76,000 a year, whereas the annual electricity cost looks like it's going to be about $45,000 a year. So in terms of pure energy savings, that's it, 30
Yeah.
G's, which is
Oh,
that's cool. That's pretty nice.
yeah, that'll help pay for the vehicle, which is
Yeah.
probably not cheap.
No, I mean it does have.
These things
Uh,
probably cost like $500,000. It's a big machine.
yeah, well, you know what? Let's ask the Google real fast. So what's the model number here? Well, you got to get running so shortly though, but it's a 25-ton excavator, by the way. Cost. Uh, the
25
internet never
imperial
lists
tons.
costs.
Yeah.
25 tons, man. So that's pretty neat. Well, I can see an
That's how you
older version
measure,
that's
that's how
not.
you measure excavators in tons.
Maybe that's what they can lift and move, but I don't truly know. So
Yeah.
I'm seeing here that a comparable unit that's not the electric version costs about 160 grand, 100 between 155 grand for a used one up to 220. So I bet you this is a
Yeah.
$500,000 machine, brand new, somewhere around
Yeah.
there, maybe more.
Yeah.
Pretty neat piece of gear.
Cool. Well, thanks for all the news, John.
Yeah.
You should probably check out our website, cleanpowerhour.com. Go to the events tab. If you haven't looked at our events tab, we try to track many of the conferences happening across the US, all the RE pluses. Just in Chicago, we have 3 great events. Midwest Expo happening in June. Check it out. I'll be there. Then the Solar Farm Summit in August. Check it out. I'll be there. That's a agrivoltaics conference. And then October, we have RE Plus Midwest. Um, so check out the events tab. How can our listeners find you, John?
Easiest, best way is commercialsolarguy.com. That's my website. We stick to it. We're there every day. I'm also on Blue Sky and LinkedIn as well if you want to get good information. So that's where I try to share. Blue Sky is number 1 for sharing for now, LinkedIn number 2, and our website number 3. So commercialsolarguy.com. That's us.
All right. Well, we'll see you again in 2 weeks on a Friday. Next time, probably not a Thursday. We had to do Thursday today because I'm flying tomorrow back home to Illinois, hopefully, if there's not tornadoes. And with that, we'll say, let's grow solar and storage. Take care, John.
See ya.